As I was beginning this video, I was trying to think of some factoring game or song that I could make, and the game Concentration, Keep Your Number, came up in my mind, and I totally thought you could do that with factoring. Factor, keep your product. And you would have to like say 2, 3, and the next, whoever that multiplied to, they had to say the next number. I know it's probably a lot, but I just thought it'd be a fun little game to play as we are all out right now. Anyhow, we are going to start our final unit today, and this unit is all about rational expressions, and it has to do with a lot of factoring, which if you remember back when I taught you guys factoring, I said this comes up a lot in Algebra 2, so here we are. So let's just go over a couple things to remind ourselves on how to factor. So remember, the first question you always ask yourself is there GCF? And also at the same time, is it in descending order? Okay. So if we look at number 1, there's not a GCF and it is in descending order. A is 1, so we can do that quick factoring of what two numbers multiply to 15 and add to 8. And that's just going to be 3 and 5. So those are my two factors. X plus 3, X plus 5. Okay. If we take a look at the second example, this one does not have a GCF, nor does it need to be rearranged. But do notice that A is bigger than 1, so we have to do bottoms up. So negative 16 and 15. So the two numbers that are going to work are 16 and negative 1. And remember that anytime A is greater than 1, we have to divide by A, the bottoms up method. So x plus 16 divided by 2 and x minus 1 divided by 2. Anything we can simplify, we're going to do that. So x plus 8 and then bottoms up, 2x minus 1. Okay. All right, moving right along. Remember that with domain, we're just going to focus on domain. We're not going to do range today. There's only two types of functions that we have to worry about domain restrictions. In our case, is square roots and rational expressions, which is what we're going to do in a little bit. So if it's quadratic, remember that the domain is going to be negative infinity to infinity. Okay. If it's, and maybe you want to write quadratic up here so you remember that. If it is linear, so if we take a look at number 5, and as long as it's not a special case, meaning a horizontal or vertical line, it's also going to be negative infinity to infinity. Okay. And number 3 is quadratic, so hopefully you recognize that's going to be the same as number 1. But in number 4, this is exponential, because remember that there's a variable, I was writing exponential at the same time, in the exponent, so the domain is going to be negative infinity to infinity. So the last one we have left that we need to worry about is square roots. And remember, with square roots, you set what's underneath the radical greater than or equal to 0. So in our case, we just have an x. So x is greater than or equal to 0. We don't need to solve for anything, so my domain is going to be, let me fix that, sorry, close bracket from 0 to positive infinity. Okay. And rational expressions are also going to have domain restrictions on them. So, and the reason being is because a rational expression is a ratio of two polynomial expressions. So we're going to say p of x divided by q of x to represent two polynomial expressions. But q of x cannot equal 0. So in other words, basically that's all that's saying is you can't divide by 0, of course, unless you are Chuck Norris. But in this case, we are not. So x, whatever makes the denominator equal to 0, can't work. So we have to take it out of the domain. And that's basically what a domain restriction is. So we can't divide by 0. So whatever x value or values make the denominator equal to 0, would be considered a domain restriction. Okay. All right. So the next page, what we're going to do is we're going to practice finding domain restrictions, stating the domain, and then also simplifying. So we're going to kind of combine these all together as one, so we're not doing too many examples. So if we want to go ahead and go to the next page, and I'm just going to go ahead and jump down to simplifying rational expressions, because we can practice finding the domain restrictions and the domain in these already. So the most important thing about finding the restrictions of the domain is to find them before you simplify. So this part is before you simplify. So before you do any type of canceling, crossing things out, whatnot, you always want to set the denominator equal to 0 and figure out what x cannot equal. So in example number 1, we're going to set 2r equal to 0, and that's what x cannot be when we're done solving it. So if we go ahead and solve for r, that means r cannot equal 0. Okay? Then that means it's a domain restriction. So basically, it's just like a break. I'm currently working on a puzzle right now, so that would be like looking across a row of puzzle line, and I kept one puzzle piece out. So basically, I'm going across the number line, and I take a 0 out. That is what will not work. So we use open brackets with our union symbol. Okay. Now we're going to go back, and we actually have to simplify. So in order to do that, we're going to look to see if we can factor, but there's nothing we can factor. So there's no addition or subtraction, so I don't have to worry about completing the heart. And I can notice that I can just cancel the r's out. Now pay attention to where the 2 is located. The 2 is in the denominator, so it must stay in the denominator. Please don't move it up. So my answer is 1/2. Now the reason why it's so important to find the domain restrictions before you cancel is because if you look at the final answer here, there isn't a variable in the denominator. So if you were to find the domain restrictions from here, you would have missed that 0 doesn't work. Okay, so make sure you find the domain restrictions before you start canceling, simplifying anything. Okay, because otherwise you will possibly miss that there was a domain restriction. So on that note, let's go ahead and take a look at number 2. So before I start canceling anything, I'm going to set the denominator equal to 0, and that's what x cannot equal. Okay, and remember that the only time we worry about what x cannot equal in the denominator is if there is a variable in the denominator, right? So if I just had an expression like this, 5x over 2, there wouldn't be any domain restrictions because there's not a variable in the denominator. Now, mind you, that's the starting, that's not, it's simplified. So we solve, if we divide by 5, we just get x plus 2 can't equal 0. So x cannot equal -2. And that is where we will have our break then. Okay. Then we go back up to our expression, and we see what we can cancel. So the 5 is on the outside of the parentheses, so I can cancel the 5s. And I'm left with x over x plus 2. Please, 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 do not cancel these x's. That's a great active note. I don't like to say things in the negative direction by saying do not, but do not cancel the x's, okay? We cannot complete the heart upside down or right side up, so we're done. The x plus 2 is attached. Remember, you cannot cancel across plus or minus signs. Okay? All right, let's take a look at number 3. So before we start anything, set the denominator equal to 0. That's what, in this case, m cannot be. So we divide by 18. So m cannot equal 0. So that means we just break at 0 for the domain. Okay? All right. I know you guys are going to be super stellar on this. Please do not start canceling the m's. So the same active note that we set over here applies to this example. Okay? You can't cancel individual terms across plus or minus signs. So just see if you can factor. So if you take a look at the numerator, I can take out a 6m squared, and I'm left with m minus 2 over 18m squared. Now, since these 6m squared is on the outside of the parentheses with no addition or subtraction, it's multiplication between the two, I can go ahead and cancel. So the m squareds cancel. This is going to be 1/3. So my final answer is m minus 2 over 3. If you left the 1 in front, it's not a big deal, but you don't need it. Okay, so once again, if you would have found the domain restrictions at the end of the problem, you would have missed that x cannot, or in this case m, sorry, cannot equal 0. Okay, we've got one example left on this page, and then I'm going to do about 2 more examples on the next page, and we're going to be done. Okay, so if you look at number 4, there's going to be a little bit more work involved in this one because of the fact that we have a quadratic in the denominator. So we are going to actually have to factor this first before I even start trying to figure out what the domain restrictions are going to be. So x is 1, there's no GCF, so I can do the quick factoring. So this is going to be x minus 7, x plus 4. So that is what x cannot equal in order to find the domain restrictions. So x cannot equal -4 and 7. So when we find the domain this time, actually, we're going to have a couple breaks, and that's okay. The biggest thing is to make sure that you keep it in numerical order. So if the break is at -4 and 7, then that means the -4, you have to break at that one first. If it was at 2 and 5, you would have to break at 2 first. So -infinity to -4, -4 to 7, and 7 to positive infinity. Okay, so make sure that when you list out your domain, you do it in numerical order. All right, so we already factored the denominator, but we do need to do some work in the numerator, and I'm just going to do this off to the side. Okay, there's not a GCF. It's in descending order, so -8 and 7. So this is 8 and -1. If I just did x plus 8 and x minus 1, hopefully you would notice that that's a mistake because a is greater than 1, so I have to do bottoms up. Remember when I taught you guys factoring, if you weren't sure when you were supposed to do bottoms up versus when you weren't, just do it every time. So let's keep that in the numerator. So x plus 4 over 2x minus 1 divided by x minus 7 times x plus 4. Now, since this is all multiplication straight across, we just need to look for factors that are exactly the same. And the ratio has to be 1 to 1, meaning I can only cancel 1 out of the numerator to 1 out of the denominator. And it has to be exactly the same. So in our case, the x plus 4s are exactly the same. So the parentheses have to match up. And I'm left with 2x minus 1 over x minus 7. I can't cancel anything else. The 2x and the -1, or however you want to think of it, are attached. And the x minus 7 are attached. You can't break them up. Okay? Alrighty. Like I said, we're going to do about 2 more problems and then we will be done. Okay? So let's go ahead and take a look at number 6. Okay. A common mistake here on number 6 is that people try to start canceling the x squareds, and then they cancel the x's, and then they cancel the 2's. You can't cancel across plus and minus signs. Okay, you can only cancel factors that are the same. So I'm going to go ahead and factor the denominator to figure out what my domain restrictions are. So x cannot equal -2 and 3. So that means my domain, going in numerical order, is the following. Okay. And we need to go ahead and factor the numerator. It's in descending order. There's no GCF, and this is the quick factoring because a is 1. So that's going to be 4 and -3. So x plus 4 over x minus 3, and then x minus 3, x plus 2. Okay. Look for factors that are exactly the same. Okay, so I can cancel x minus 3's, and I'm left with x plus 4 over x plus 2. That is your final answer. Please, 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 please. Do not make this, x plus 2 over x plus 1, or sometimes people will cancel this to 4 over 2, which equals 2. You can't do that. The parentheses have to match up when you cancel, and the ratio has to be 1 to 1. Okay. All right. One more example, and then I'm going to give you the answer to one of the problems if you want to try it on your own. But other than that, the video will be done. All right. So let's go ahead and factor the denominator, figure out the domain restrictions are. So I'm going to take out a 4. X squared minus 3x minus 10. Okay, we don't have to worry about the 4 because it doesn't have a variable with it. So x cannot equal -2 and 5. So my domain is going to be -infinity to -2, -2 to 5, and 5 to infinity. Okay, notice that I'm finding, again, the domain restrictions before I do any type of canceling or simplifying. All right, let's take a look at the numerator. So I can take out a 2. And some of you might notice right now that these two are exactly the same. That's great if you did, but we can continue to factor this. That's okay. Okay. So let's put this all together. So we have 2x minus 5 times x plus 2 out of the numerator. And we have 4x minus 5 times x plus 2 out of the denominator. Then we look for things that are exactly the same. So x minus 5 are the same. X plus 2's are the same. You're left with 2 over 4, which is 1/2. Now, if you notice that, they would have canceled from up here, that's fine. We just had to do the factoring all the way through in the denominator in order to find the domain restrictions. Okay. All right. I'm going to give you the answer to G if you would like to try that problem later on your own. Okay. So when you are done factoring and simplifying, you should get x plus 5 over 2x minus 3. And then your domain restrictions are going to be -infinity to 3/2, 3/2 to 5, and 5 to infinity. So that would be a good example to try later on, just because the numerator is going to factor by dots. Remember, that's the whole a plus b times a minus b. And then this is going to be bottoms up. So it's a good practice on different types of factoring. Okay. I hope you guys all enjoyed the lesson today. Remember that algebra is like weightlifting for your brain. And we can do it. We're going to get stronger each day. Okay? I hope you all have a wonderful day or night. Thank you.